Hello, welcome to lecture 39 of game theory. Okay, we were about to entering the dynamic incomplete information game, and by that we are going to introduce a new equilibrium concept, which is kind of equivalent to the subgame perfect equilibrium in complete information game. Okay, of complete information game. Now we are talking about incomplete information game, and the counter concept of subgame perfect equilibrium here is perfect Bayesian equilibrium. Okay, what is it? The example I'm going to talk about, I'm going to explain by the example, is the U.S. and North Korea game. I've been using this example for the last 20 years. Nothing has changed. Okay, sometimes the US, North Korea seems to be get together, sometimes not. The North Korean leader used to be not Kim Jong-un, his father Kim Jong-il, but the US president changed a lot. But all the time, the situation is very similar. The US may choose the status quo, do nothing. Okay, the patience, like a patience policy or something. And then US may attack, may economic attack, military attack, whatever. US may pressure attack North Korea. The North Korea, of course, would feel better if US stay away. The first number is US, second number is North Korea. If nothing changes, US 0, North Korea 0. If US attack or pressure North Korea can fight or resist or just surrender. If North Korea surrender, North Korea gets -2 and US gets 1. US wins. US would be happiest if US pressure attack North Korea and North Korea kind of give up, surrender, okay, we'll be obedient. Then US change from 0 to 1. And North Korea changed to 0 to -2. Okay, why there are two lines, I'm going to explain. US may attack North Korea. North Korea may, instead of surrendering, they may fight. If they fight, there's no doubt USA will win. How can possibly North Korea win over US? So if US pressure attack North Korea fight, then US will win. Still, for US, it is not as good as, of course, North Korea surrender. More than that, it is not even as good as status quo, because when US pressure, North Korea fight, it's real attack, military attack, North Korea fight, some USA soldiers would be dying and South Korean cities would be destroyed because North Korean missile, etc. So USA, it's -1. So from USA point of view, attack North Korea surrendering, that's the best choice, having 1. Just status quo, do nothing, would be 0, second best. Attack and North Korea fight, that would be the worst, -1. Okay, but realistically, if you are the leader of North Korea, are you willing to fight with USA? And it's 100% sure you will lose. Not only you lose, you will lose your life. Think about that. If North Korea shoot a missile to Korea, South Korea, Japan, or even USA, done. USA militarily attack North Korea and everything would be annihilated, especially the North Korean leader would be captured and killed, like Gaddafi and things like that. So, if US really attack and North Korea fight, means maybe they are shooting missiles on South Korea, Japan, and USA, that would do some damage to USA, but that would be the end of North Korean leadership. That is why this minus x can be like x would be bigger than 2. Minus 5, minus 6, minus 10. So it cannot be good. Okay? Because you fight head-to-head USA, you'd be defeated hugely. That is the first line. So it's like minus 1, minus 5, minus 10, 1, minus 2. So surrendering is humiliating, and a lot of rights of North Korea would be lost. However, North Korea will still survive. On the other hand, if North Korea fight against USA, minus 10, something like that, North Korea will lose hugely. So x is a number, something bigger than 2. Okay, so that fight is never as good as surrendering. For sane type, okay, now because we are dealing with incomplete information game, I'm going to assume that there are 2 types of North Korea. If North Korea is sane, okay, think about the first line and put 5 in x, minus 1, minus 5, 1, and minus 2. Would USA attack or status quo? Status quo, USA will get 0. If attack, North Korea would wonder, should I get negative 2 or negative 5? X is 5. Of course, North Korea will choose surrender. So USA, attack, surrender, that would be subgame perfect equilibrium. Okay? I'm not saying that it is complete information game because we know that X is 5 and North Korea is the sane normal people. I mean, that would be so easy. The US will attack North Korea immediately, North Korea will surrender immediately, and Korea would be reunited, and there would be a peace in Korean Peninsula. How can this not happening for the last 70 years in Korean Peninsula? The main reason is the North Korea. Many people around North Korea think North Korea may be crazy. Insane means crazy. Sane means normal. Insane is crazy. North Korea may be crazy. They are not like normal people. Look at the North Korean leader. Do you think they are like normal, like president, prime minister, or something like that? No, they look crazy. They behave crazy. What does that mean? North Korea may enjoy fight with USA. Okay, North Korea's purpose is not surviving. North Korean leadership says, okay, we want to die. What is best for the crazy leadership of North Korea may be, US, please attack us. Then we'll fight. Of course, all North Korean soldiers will die. All the leadership, the Kim Jong-un will die. However, we are going to kill maybe 20,000 US soldiers. That would make us feel great even though we are dying. So, the best thing is US attack, North Korea fight, and probably you die, but still fight and kill some Americans, soldiers. That is 2. Second worst, US stay out, status quo. North Korea get 0. The worst thing is US attack, North Korea surrender, and getting minus 2. I mean, you have a expression that somebody has a death wish. And, if someone has a death wish, we don't think he is a sane, normal person. He must be crazy. And there is wide perception that North Korea might be just like that. So, if North Korea is poorly prepared country, only some missiles, but no match for America, no match for Japan and Korea. However, they're going to shoot it. And then, because of North Korean missile, millions of Koreans will die, millions of Japanese will die, and tens of thousands of USA soldiers will die. And USA, Japan, Korea think, it's not worth it. Okay? We don't want North Korea that much because so many people will be killed and the economy will collapse, even though North Korea will be annihilated, that is not really what we want. That is not even as good as status quo. Stay as it is. Okay? So, the possibility that North Korea may be mad, they are insane, kind of give a pause to USA, Korea, and Japan from attacking North Korea. Okay? If this happened just once, that is kind of Bayesian Nash equilibrium. But let's assume that this game is repeated twice. If this game plays once, North Korea, sane type will surrender, insane type fight. Crazy fight, sane surrender. There is nothing special about that. However, if this game is played twice, what will happen? The North Korea who's sane may be thinking, okay, US attack us today. If we surrender, US will keep attacking us in the future and will keep surrendering. So, even though I'm saying fighting US would be worse than -2, but today I'll just fight. Then USA will feel, oh my God, North Korea may be crazy. So we expected 1, we got -1, and that's probably because North Korea is insane. Therefore, we'll stay out. So you just fight against USA like crazy, even though you are not. If USA think you are crazy, then US will not attack again. So you will get 0 instead of -2. So the sane North Korea may pretend to be crazy if this game is played twice or more. Especially the first period, the North Korea, of course, crazy North Korea, insane North Korea will fight. But even the sane North Korea might be thinking about fighting in T1 so that it gives USA the first impression that North Korea is crazy type, not sane type. Therefore, USA giving up attacking North Korea again in the future. So one big negative, then 0, rather than -2, -2, -2, -2 kind of thing. Okay? So there is a danger of that kind of fake action in this game. Okay? Perfect Bayesian equilibrium. Okay? Dynamic game. As I said, perfect Bayesian equilibrium makes sense only in a dynamic game. Of course, it should be incomplete information game. Otherwise, we are dealing with a subgame perfect equilibrium. The main difference between perfect Bayesian and Bayesian Nash equilibrium is perfect Bayesian, because it's dynamic game, someone move first, someone move second, there is a chance for the player to observe the action of other players. For example, in this game, the USA in T1 may be attacked, North Korea may fight, surrender. Then USA, even though it does not know whether North Korea is sane or insane, it fight. USA might be more tilting toward, oh, North Korea may be crazy. If North Korea surrender, USA will say, oh, definitely North Korea is sane. So we are going to attack and attack again. So what is this? This is updating the belief. At first, you maybe just half and half. The North Korea may be crazy with 50%, sane with 50%. But if you see North Korea surrendering, because, if the crazy North Korea will never surrender. They love fighting. That's why they are crazy. So if they surrender, immediately your probability that North Korea may be sane 50%, sane 100% if they surrender. So by observing the action of North Korea, you update the type of North Korea based on that. You have that chance, opportunity in perfect Bayesian equilibrium in dynamic incomplete information game. As I said, of course, the other party, North Korea, also have a chance. The U.S.A. have a chance to figure out North Korea's type. North Korea also has a chance to fake each time. Okay? So that means this, chance to pretend to be something else. So the one who has a type, because of chance of observation, has a chance to pretend to be something else. On the other hand, the one who does not know the type of the other player can have a chance to observe and update its belief. The beliefs should be updated according to the Bayes rule. Okay, there's a rule in statistics how to update based on the observation. Okay, that is the Bayes rule. And basically, they have to calculate the new belief probability based on their observations. Like conditional probability. If someone acted like this, based on that, what is the new probability belief of this? The strategy should maximize the player's payoff, given the beliefs updated. That's exactly the subgame perfect equilibrium. So the rule in perfect Bayesian equilibrium, you should update the belief according to, not just anything you want, according to the Bayes rule in statistics. And then you have to maximize your payoff by choosing strategy based on that updated belief. That is the condition for something to be the perfect Bayesian equilibrium. Okay? There are basically three groups of perfect Bayesian equilibrium. A game can have only one of these, like separating, for example, separating, pooling, and hybrid. One game may have only separating equilibrium, or that game may have separating and pooling together kind of thing. But anyway, the classifications are basically there are three classes, three groups of perfect Bayesian equilibrium. Number one, okay, different types, different action. What does that mean? North Korea, sane, crazy. If North Korea is sane, North Korea will do something A. If North Korea is crazy, North Korea will something B. So as soon as you see whether North Korea did A or B, you can tell definitely whether North Korea is crazy or sane. You are going out a date with your boyfriend. If the boyfriend maybe give a coin to a poor homeless person on the street, and if it's a separating equilibrium, he's a nice guy. If your boyfriend does not give it to the homeless person, he's a bad guy, kind of thing. Okay? For some reason, the good guy gives coin to the homeless, the bad guy does not give coin to the homeless. That kind of thing. Okay? You're wondering whether the professor is a nice person or not. If the professor call your name, remember your name, he's a nice guy. If the professor does not remember your name, he's a bad guy. Somehow, the bad professor never remember your name. Somehow, the good professor always remember your name. Then, whether the professor remembers your name or not is a clear criterion to see whether the professor is nice type or bad type, nasty type. So the different types act differently. In other words, if you look at the action, then you can tell that they are types immediately. It's like separating. You can separate one type from the other. That's the separating equilibrium. Sometimes in perfect Bayesian equilibrium that happens. Pooling equilibrium. Different type, same action. I mean, you are dating a boy. He's a nice guy. He give money to the homeless person on the street. He's not a nice guy. Still, he gives money to the homeless person because he wants to look nice. North Korea, when U.S. attacked North Korea, the crazy North Korea, insane North Korea fight. The sane North Korea, of course, it's better for the sane North Korea to surrender, but they fight because they want to look like the nasty, insane North Korea. Understand? The nasty professor, they are not supposed to remember your name, but they want to get a good evaluation. They want to get you in their class, so they try very hard to remember your name. Then the professor remembers your name. Every professor remembers your name. So you cannot use this criterion to tell the good professor from bad professor because everybody acts the same. That's pooling. So the one type pretend to be another perfectly. So even though you observe, your belief cannot change because every type acts the same. That's pooling equilibrium. What is hybrid equilibrium? That is same as mixed strategy equilibrium. What sense? It's mixing of separating and pooling. The good boyfriend always give money to the poor people, homeless people. The bad boyfriend sometimes give help and give money to the poor homeless person. Sometimes they don't. They're randomizing between and helping and not helping. The insane North Korea, they always fight with U.S.A. The sane North Korea sometimes fight with U.S.A., sometimes they don't. So they are kind of mixing and randomizing behavior. Okay? So those are three groups of perfect Bayesian equilibrium. Okay? Okay, now let's write them down. Okay? I'll move. If you look at this, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if I'm warning you, if someone asks you to find out perfect Bayesian equilibrium in this game, okay, here, which is played period 1, period 2, you have to write down 9 things. You forget one thing, period, you got 0 point. All 9 things to accurately answer of my question, to accurately write down the perfect Bayesian equilibrium. It is that complicated. Just look at what are they. The North Korea, insane. I means insane, crazy. North Korea, S means sane, means normal. So North Korea, because there are 2 different types, North Korea insane, North Korea sane, and U.S.A. So even though there are 2 players, U.S.A. and North Korea can be sane, insane. So we have to treat it like a 3-player game. U.S.A., sane North Korea, insane North Korea. Already 3 things to be considered. Then we have period 1, period 2. So U.S., how would it act in period 1 and period 2? The sane North Korea, how will it act in period 1, period 2? The insane North Korea, how would they work in period 1, period 2? So already we have like 3 players in period 1 and 2. So we have to at least 6 things to describe. But then one more. In the second period, the U.S.A. first period, they will just act. But when in the second period, they have chance to observe whether North Korea fought or surrendered in the first period. So the second period U.S.A. strategy should be, what would I do if North Korea surrendered in T1? What would I do if North Korea fight in T1? So we have 7 things to describe. And there are 2 beliefs we have to describe too. We are going into that in the next lecture, lecture 40. This has been the lecture 39 of game theory course. We have just finished week 13. We are entering the final week of the lecture. Thank you.